Welcome, Sam. You want to do a quick intro on yourself?
Sure. I'm Sam. I guess I'm the originator of the Arweave protocol, which is a permanent information storage system. Should we?
That's good. Let's dive in.
All right. So, yeah, Arweave is the global permanent hard drive. The idea is to build a protocol that stores information and knowledge forever. We got into this in the first place by thinking about what tools would be needed to stop a kind of modern authoritarianism developing, and one of those is obviously to stop centralized parties controlling what we would call the information space, so access to history. As George Orwell put it, he who controls the past controls the future, he who controls the present controls the past. We wanted to kind of break that link and make it so that you couldn't, by just controlling now, control people's ability to understand what has happened in the past. Because if you do, then you can change the way they act in the future. You can change what they pay attention to, and so on. It's a protocol, if my clicker works, that is aiming to build a kind of modern Library of Alexandria that can't burn down. Obviously, the problem with pretty much every archive, from the earliest archives, Library of Alexandria, all the way to present-day archives, is that they have a single centralized point of failure. Right? There's some place, physical location, at which the data is stored, and you either go there with a fire, a flood, or the government comes, and that data is gone. Right? It's a fundamental problem. Obviously, blockchains contain kind of roots, or would you say the seeds of the solution to that problem, being globally replicated data sets, more or less. Problem is, obviously, they don't store large amounts of data. So we decided to solve that. And the protocol is essentially made up of two components at the base layer: a storage endowment, which is a sustainable mechanism for paying for the storage of data perpetually, and a system of mining on top of data. So moving the proof of work, would you say, value expenditure, essentially, from just wasting electricity, guessing random numbers, to actually replicating data. And the more you replicate the data, the more you're rewarded. So first component, the storage endowment. There's some really elegant math behind this, but basically what it's saying is that the price of storing should be the infinite sum across the data size multiplied by the price of storing a gigabyte for an hour at the current time. And of course, as the time changes, the price for storing that gigabyte changes too. Actually, it exponentially decays. And so essentially what you end up with is an infinitely decaying series. You can sum the area under that curve and get yourself a single value for infinite or indefinite term of data storage. Obviously, you don't want to depend on data storage cost decaying at a high rate. You want to depend upon it decaying at a very, very low rate. And so we say 0.5% when across the last, I'd say, 50 or 100 years, the declining storage cost rate has been about 0.5%. So there's a 61x safety margin in there, something like that. On the other side, succinct proofs of random access basically say, OK, well, when you are trying to mine a piece of data, let's link it, or a new block, let's link it back to a randomly chosen previous piece of data. So every time we try and mine a block, we generate a series of challenges, basically billions or trillions, maybe even quadrillions now. I would have to check the difficulty, but of challenges where we say, OK, go get me this byte from the data set. Go get me that byte from the data set. And then we use Merkle proofs to say, OK, sure enough, this byte is found in this chunk, which is found at this location inside the data set. And then you fulfill a proof of work puzzle, basically, on top of this data, which is really just stressing your link to the data set, like your hard drive speed. And you see whether you pass it. And if you do, then you go and mine the block. And if you don't, you just do it again. And then you just basically poll the data set until you find a new block. So that's the Arweave protocol. This is the kind of base layer, we would call it. And on top of this lives what we call the permaweb, which is all of the information stored inside this exposed in people's browsers, whether that be a mobile phone or on a desktop or on a laptop, whatever it happens to be. The interesting thing here, of course, is that yes, you can have like static documents, so documents, videos, that kind of thing, but you can also store full applications on top of this system. And because you can speak to the network as a database, you can say, hey, give me, for example, every transaction from this wallet address with this set of tags between this date and that date. Something like a query you'd use to get a social feed, for example. You can get that served back to you and your application and have it rendered. So these look like fully dynamic web applications that are completely decentralized. And we're looking at working with many people on the decentralization of that indexing part, but the graph would be one of them. Yeah, so this is really exciting because it allows you to build decentralized web applications that live forever and, crucially, report to nobody. So they're web applications that are kind of, if you like, protocolized in the sense that there's no single owner or controller, and nobody will be able to stop you getting to that interface in the future. So the example I always give is Weavemail. Weavemail is a kind of decentralized email-like system built on top of Arweave. When you go to weve.email, you get back a UI. Nobody in the future will be able to stop you accessing that UI. It is like permanently available to you. They also can't change it so that it's going to steal your data, serve you intrusive adverts, or whatever it happens to be. Like, that application is available to you in that form or better, if somebody issues a new front end for it, literally forever. And no one can take away that access. Those are PermaWeb apps. Recently, usage of Arweave has exploded, and we mean like really exploded. This is not just like generic startup talk. This kind of exploded. So Arweave has been picked up in the Solana NFT ecosystem over the last few weeks, and has led to, frankly, insane amounts of data storage. It's been pretty cool to see. And this is a graph of the transaction chart since the beginning of Arweave, which launched like 3 years ago. You see it's pretty much exponential curve. What's really cool is that this last component here, September 2021, that's just so far this month. So there's about 10 more days to go. So you can expect that to be, well, you imagine what the graph looks like. But probably the coolest thing is the Web3 index. Arweave is the most used Web3 protocol by a factor of 3-fold right now in terms of actual revenue generation. And this is a great project put together, by the way, by LivePeer, who take all the credit for making this cool index. Yeah, we thank them very much for that. It's, I think, a great thing to keep the Web3 industry on track to focus on actually who is using the protocols and what are they using them for, rather than just the token prices. But anyway, where is the growth from? So this is Anatoly, one of the founders of Solana, when describing a conversation we had when they were putting together Metaplex, which has ended up being by far the largest NFT platform on Solana and probably the second largest NFT platform overall. And he just, we got on a call and he said, hey, we're going to use Arweave for storage. And I said, that's great. What do you need? And they're like, oh, nothing. It just kind of works, which is the best thing you can possibly have in protocols, I would say, because there's often far too much complexity. And it's nice when things just get out of your way and they serve a function well. So a lot of NFTs, but also recently, and somehow I think most of the industry kind of missed this, Arweave's become the base layer storage system for a bunch of different chains for their actual blockchain data itself. So obviously, a blockchain is an ever-growing ledger, right? You put more transactions in it, you put more blocks in it, and it just keeps going. Like, at no point is it really going to prune. There was actually a part of the Bitcoin paper about that, but no one's ever used it. That's great. Well, it's not great. It's not too bad in the case of Bitcoin, right? Because it grows at a fairly small rate. But the more scalable your blockchain is in general, the more of a problem this becomes. So in the case of, for example, Solana, they're doing literally, I don't think people realize this, but at peak they get to like 500,000 transactions per second. It's a lot of transactions. You've got to store them somewhere. Well, Arweave is a permanent storage system that is actually well replicated and also incentivized, which people can just tap into. So someone from the community, or a couple of people actually, built this effort that they call Kive, which essentially went out and partnered with all these different blockchains. So that's Polkadot, Solana, Cosmos, Near, Avalanche. I think there's a bunch of others, but I can't remember which ones are public and which ones aren't. So just say, go check out Kive.network to find out. But basically, all of the other major layer 1 blockchains in the space said, OK, well, we'll just store your data for you. And now you have easy, fast access to it that you can embed inside your blockchain nodes so that people can get up to sync faster, and you don't have to worry about losing the data. Just kind of fundamentally solves that problem. So we've seen a huge amount of pickup in this place, or in this space too. And what I'm really excited about for the future is actually that these are just the tip of the iceberg, the most obvious use cases for the system. Once people realize that you can build a fully decentralized social media system on top of this network, which answers to no single person or company, then I think what will happen will put to shame our pretty expansive growth so far. OK, final component, I guess. We're also seeing a reasonable amount of pickup in places where censorship is a serious local problem. So there was an incident where the Daily Apple, a newspaper from Hong Kong, was basically, well, taken offline is the expression of what happened in cyberspace. But they were shut down because of the national security law in Hong Kong. Well, some people from the Arweave community noticed this and managed to, in time, build an archiver that went and just scraped up a huge amount of that data and put it on the network. And this we see increasingly. Like, this also happened back when there was the call for, or the hashtag was I demand my freedom of speech on Weibo back in March 2020, or maybe February 2020. Someone managed to build a scraper and put as much of that information as they could on top of Arweave. And so we really see this niche building for properly censorship-resistant storage as well. OK, yeah, you can learn more at arweave.org or just kind of follow us on Twitter, I suppose. Thank you.
Awesome. Thank you, Sam. So let's start with that very exciting use case you brought up towards the end of the slides with archiving a bunch of block history. Right, I think that's definitely a problem that needs to be solved. I guess the first question that jumps into mind there is one of trust, right?
Cost.
Where,
yeah, you're contributing to an endowment rather than paying for storage directly. So cost is about ½ cent per megabyte.
I'm sorry. The question of trust.
Trust.
Yes. So in archiving a bunch of this history, someone's archiving it. Right?
Oh, yeah, that's an interesting thing. Right. So there's obviously this question if you're bridging blockchains. Well, you can't take one node's point of view on what the state of the network looks like. And so Kive have solved this by basically having a DAO, or a sub-DAO, you could call it, on the SmartWeave side on Arweave, where one person is nominated to be the archiver, and the others are nominated to be validators. And then they basically, one of them stores, the others check that what is being stored is correct, and if it's not, they all vote to say, hey, that wasn't correct. Let's slash that person's stake and nominate someone new. And then they swap them out, and it continues. And you just evict from the Kive side log. Obviously, you can't evict the data, but you just change the way it's displayed to users, basically, to get a consistent stream of the right data.
And so this is just a dApp that's built on top of Arweave with its own economics.
Exactly. So all of this exists in the kind of permaweb app space, you would say, on top of the core protocol. I mean, everything about Arweave is built as a hyper-modularized component-based system. So you can swap out bits that you don't like. There's actually, 3 or arguably 4 different smart contracting systems built on top of Arweave now. In the core, we don't have any smart contracts at all. But we have SmartWeave, Redstone, Everfinance, and another one that I've forgotten the name of is kind of earlier stage, that all use Arweave storage in order to produce smart contracts for users. And so it has this, we have this theory that in protocol adoption, the more choices you make, the less likely you are to get consensus that your protocol is the right protocol. Because choice is something that someone else can have a different opinion on, right? And so the whole point of protocols is to just have social consensus that this is the way we do something. It's not for the protocol to be perfect. And so by pushing out choices into extra layers on top and different components, then we can say, OK, guys, you have whatever preferences you want at layer n on top of this thing. You can, it'd be great if there was even competition, right, between the different smart contracting platforms on top of Arweave. That's great. But let's all just agree that the base protocol is right.
Yeah. Neutrality at the base layer as a means to continue building the community. Or facilitate choice.
We like to see it as the community is built around the base layer, and then there's lots and lots of choices and modules on top. And then, so for example, Everfinance has an EVM-based system. It's actually really interesting. They call it storage-based compute. But the basic idea is kind of like the hyperextension of a rollup on Ethereum. So rollups are pretty much saying, wait, actually we can ingest large amounts of data at once rather than one by one, and then we can cut down on transaction header distribution as a cause of congestion. That does make sense, but they're missing a trick, which is, well, you can also just delegate computation as well, which Everfinance picked on. And it kind of said that, there doesn't need to be any computation in the chain at all. Actually, what you have is consensus about inputs to things. But anyway, so Everfinance offers EVM-compatible smart contract systems that go like, tens or hundreds of thousands of TPS built on top of Arweave. And then there's another system we call SmartWeave, which is kind of like slightly adjacent idea of just using literally JavaScript VMs to execute smart contracts because there is no execution in the consensus layer. The execution happens on the client. And so these are two different two different ideas in the same space that might suit different developers, better or worse, right? So you can have both exist on top of the same thing. But if you make it modular and so that people can choose which one works best for them, then you don't have to have this concern of the protocol is going to be adopted all or nothing, right? It can be adopted piecemeal. And that, I think, is actually a more effective way of doing it.
Makes a ton of sense. So Arweave takes a very different approach to storage, right? As this permanent replicated layer that kind of goes on into perpetuity, and that has like a different use case from traditional storage models. And the obvious ones that you pointed out, like NFTs, you want them to be around. Block history, you want it to be around.
Right.
How has your team gone about like engaging with communities and finding use cases where people want to leverage this permanence?
We focus on speaking to developers. We listen to what the developers want, and then we find a way of serving it. And yeah, I mean, it's kind of guided us so far. Like you see with Anatoly there, like it just does a useful thing, and it does it easily, so people tend to like to use it. The question is speaking to enough developers, right? I think also an interesting question in the Arweave space is we don't really speak to any speculators. We're probably one of the least speculator-focused projects in the crypto ecosystem, and there's a question as to how that will play out. But the way that we see it is if you become the backbone of all of the useful applications, and you kind of see this on like the Web3 index, like huge amount of the usage, actual usage of Web3 applications is going through Arweave nowadays. Yeah, we have this theory that longer term, if you become the backbone of things, people will eventually notice, and then the rest will follow.
So this is like the one instance where build it and they will come is playing out.
Well, it's like build something that is genuinely useful and iterate on it early, and they will come, hopefully. Well, and they will hear about it through word of mouth. That's how it actually happens. People tell each other about Arweave because they like it.
So you mentioned like talking to enough developers. How have you gone around building like your DevRel team or your team of? How is community engagement like with the developers built out as a lesson to all the other community builders out here?
Yeah, I mean, like the tough thing at the beginning was bootstrapping, right? So, I mean, I started Arweave, and when I did so, I just had a few friends that I knew would be interested and were passionate and smart people that you want to work with. That was great to start with, but like over time, we kind of had to pivot into this, into where we are now, which is like, that was great, this is far better, which is literally we just hire good people from the community when we need something done. And actually, we don't even hire them. Our team is about a dozen people. It's really small, but the amount of people that wake up every morning and build on Arweave stuff is about 100 or something like that. And that's because instead of trying to centralize the value creation inside our organization, instead what we do is we see, okay, so Hive is a great example. We saw that there was this niche that needed serving of like storing chain data inside Arweave. We worked with Solana on the first one, and we did like a small grant with someone in the community. And then Polkadot wanted the same thing, so we said, okay, cool, we'll do the same kind of idea. And then we realized, actually, just as you picked up, you want this data to be verified. So how are we going to verify it? We built a business model, and then we found someone in the community that wanted to go build that business model. Then we put capital behind them, a little bit at the beginning, and then now, $5 million of raise later, they have this like really growing project building on top of Arweave. And so we've done that like dozens and dozens and dozens of times. And you end up with this really decentralized ecosystem of people that are passionate about the project.
That's really cool. So just switching gears a little bit, who's providing storage for Arweave right now? What's the community of?
Random people. Lots of people got into Chia, and then the rewards on Chia went down, and they started mining Arweave. I mean, the cool thing about crypto economics, right, is that I don't have to care. Like, we get the crypto economics right. We don't have to care who it is that is providing the storage. In fact, I always joke about the fact that for about a year, 25% of the Arweave storage was provided by a guy that called himself Slayer Hellraiser on a Discord server. He's like the least trustworthy guy you would imagine. But it didn't matter, right? Because the crypto economics kept him in check. And that's the really cool thing about these systems. So yeah, I don't even know is the answer, and I don't really have to care.
The trust between mutually distrusting parties, right? That's the
Trust the math, don't trust the people, something like that. Yeah.
fair enough. Fair enough. So, do you have any like sense of like what the distribution of like the data storage providers are, or the geographic distribution of like where the stuff is actually being stored?
Yeah, lots in China, lots in Germany for some reason, some in the US, some in Canada, and then kind of exponentially decaying curve after that. It's probably like a few dozen different countries.
Gotcha. And all that has happened without a biz dev team that's going around rallying people to run servers. And
Yeah, I mean, the funny thing was, like, we've actually spent much more time and focus on carving the protocol to have what we would call like protocol market fit. Whether that's changing the base protocol a little bit in the early days, but nowadays just making sure that there's bridges, like Kai, for example, that make the protocol's utility available to the people that want it in the form they want it. We spent a lot more attention on that. I would say actually all of our attention on that, and 0% of our attention on getting enough data stores. Strangely enough, that was just something that happened completely naturally.
Awesome. Sam, you've got 20 seconds left. Anything you want to leave the audience with as we wrap up?
No, but if you're interested, just like come find us on the Discord server. There's like hundreds and hundreds of developers building cool stuff that you might want to check out.
Excellent. Thank you, Sam.